All right, so example 6. Okay, the limit as x approaches 0 of this function. So if we subbed in 0, we would again get 0 over 0. This is indeterminate form. We cannot do anything with that. Therefore, we have to work with the fraction first. In this case, we actually have to use something called substitution. So what I want to do is I want to substitute, usually we use the letter u, and I want to substitute that in for x plus 8 to the 1/3, because that's really ugly, right? So limit as x approaches 0. And if we think about it, if we want to rearrange this for x, because we have to actually sub in for x at the bottom. So on the top, we would have to sub in, as for the x plus 8 to the 1/3, we sub in u, okay? And then it's minus 2. Now, it's only an x at the bottom. So we have to take this substitution, and we have to isolate for the x to get x as a function of u. So if we raise both sides to the 3, we'd have u to the 3 equals x plus 8. Bring that over, u cubed minus 8 equals x. In this case, this x at the bottom, we're going to represent as u cubed minus 8. Okay? Now, instead of writing as x approaches 0, we're going to write as u approaches 2. Okay? Start with that, as u approaches 2. And where we get this 2 from is we had u equals x plus 8 to the 1/3. So if we were talking about x approaching 0, we would do 0 plus 8 to the 1/3. And 8 to the 1/3 is just 2. So when we sub in x equals 2, so like, x equals 0, because x is approaching 0, we actually get u equals 2. So we want to deal with when u approaches 2. Okay, so we're going to leave the numerator, and the denominator, what we're going to do is we're going to actually just factor it. So we actually get u minus 2, and we get u squared plus, remember, it's cube root of the first thing, cube root of the second thing, and then 2 times that. So we get 4u, or it's 2u, and then cube root of the 8, and then square that, which is 4. Okay, if you want me to go over that really quickly, let's go. A cubed minus b cubed, and that's going to factor to a minus b, and then it's going to be a squared minus plus ab plus b squared. That's what it's going to factor to. Okay, and again, that's a recap from advanced functions. Okay, in this case, there's a hole at u equals 2, doesn't matter, cancel those out. We have the limit as u approaches 2 of 1 over u squared plus 2u plus 4. Now, everything in the denominator is an addition, therefore, we're no longer going to get a 0 in the denominator. Let's work that out. 1 over, we have 4 plus 4 plus 4, 4, 12. We get 1 over 12. And that's it for this question. It's just 1 over 12. Okay, next question. So we're going to deal with an absolute value. And if you remember back from advanced functions, an absolute value is just actually like a piecewise function. Okay, so let's just try 2 minus 2 absolute value over 2 minus 2. Again, we get 0 over 0. Indeterminate form, we cannot use that. So we have to break this down. So let's consider the absolute value function. So we're going to deal with x plus 2 when x is greater than 2. And we can just go ahead and put the denominator there as well. And we're going to deal with minus, so like the flip of x plus 2, again, over x minus 2. when x is less than 2. Sorry, these are minuses. I kept saying plus. That's a minus. Okay? So, in other words, let's actually just simplify this. Okay? So, f at x, here we go. F at x equals, we can cancel those two out. So, our piecewise function now is going to be 1 when x is greater than 2, and -1, here we go, as x is less than 2. Okay? So in other words, it doesn't even matter what's actually happening at 2, and that's a good thing because there's going to be a hole at 2 because we cancel them out, numerator and denominator. But that's fine. Let's call this 2, and let's just go like this. Okay? Oh, so sorry. When x is greater than 2, we're dealing with the horizontal line 1, and when x is less than 2, we're going to deal with the horizontal line -1. Okay, therefore, the limit as x approaches 2 from the left of f at x does not equal the limit as x approaches 2 from the right of f at x. Therefore, the limit does not exist. Okay, final question. So, evaluate the limit as x approaches -3, or 3 from the negative side of root 9 minus x squared. So when we actually consider 9 minus x squared, we are considering the circle, only the top part of the circle. That's really, really bad. Okay, only the top part of the circle, right? From -3 to 3. Okay? Because remember, the circle is also a piecewise function. For the top, it's like, for example, 9 minus x squared, and at the bottom, it's like the flip, like the reflection in the x-axis. Okay? So there's nothing down there. So let's consider the limit as x approaches 3, maybe just 3 in general. So explain why the limit as x approaches 3 from the positive side cannot be determined. Okay, so 3 from the positive side. There is nothing going into that 3 from the positive side, so it's just undefined over here. So this undefined, this equation, it's not in the domain. Okay, and what can we conclude about the limit as x approaches 3? Like, the limit will not exist as x approaches 3. Okay, so the limit does not exist because from the left-hand side, it's approaching 3, but from the right-hand side, it's undefined. Okay, so we can say the limit as x approaches 3 from the left-hand side equals 3, or from f at x equals 3, but the limit as x approaches 3 from the right-hand side of f at x does not exist.